Y'all. Oh, there's the mic. I tell you, the only thing I could think of since leaving this game last night and then finally getting back to it today is I just wanted to play more. I just wanted to play more. I wanted to get to some newer challenges, newer puzzles. I also went, and even though you guys will see all these videos afterwards, I actually did go and add all of those videos and links to the description below, so they are definitely there now. I can confirm that. And I also brought with me my little deck box with Final Fantasy cards inside and some dice. Got some dice. I want to show off some cool dice. So like I was saying, that the 5 Platonic solids are all here. Here are the 5 Platonic solids that we were talking about last time. Look at that. You got the D4, all triangle sides, 4 triangles. You get the D8, which is 8 triangles. You get the D20, icosahedron, 20 triangles. You get the D6, normal dice, 6 squares. And then you get pentagons, 12 pentagons. And those are all D&D dice. In D&D, there's also a 10-sided dice. But you can see those shapes are a little bit weird. Maybe you can see. I really don't know how this camera focuses, but you can see they've got some kind of weird shapes to them there. So not quite correct. They are the same, but it doesn't have perfect rotational symmetry is the problem. So let's go. I just wanted to get that out of the way, and all that stuff's down in the comments below. Let's go. Space Tow Truck. I've just been waiting all day to play some more of this. Oh, honestly, like it's I'm very excited to jump back into it. Yesterday we got trolled by the simplest puzzle in the game, maybe, and I was just too stupid. So we're gonna jump right into World 4. We've figured out that you can actually stop once you've started moving, which probably was very obvious to some people, but I don't know why I blanked that out. We're in the oceans of storms. It owes its name to the fact that in the 17th century it was believed that the phases of the moon had an influence on weather conditions. Thus the first quarter of the moon was associated with good weather, whilst the last quarter was associated with bad weather. Since the seas were formed after the formation of the moon, they have fewer craters than the rest of the moon's surface. It is quite logical. 4.1. Introduction to the concept of delta velocity. Ooh. Oh, let's go. What's this then? What are we going to be talking about here? Delta velocity. I can put these dice. But I also have a round dice, which is very bizarre. It's a 6-sided round. Well, not 6-sided, but it's a 6. It's supposed to be like a D6. Has a little weight inside, which I assume is a 6-sided dice, and then so it kind of lands on one of those sides in the weirdest way possible. It's my favorite dice by far. Remember, electrical impulsion gives your vehicle the ability to alter its velocity by a specific amount called delta velocity. It does not allow you to directly choose your velocity. So it's the same as at first we could teleport to a position, but then we had to displace our position from where we currently were. And now I'm pretty sure this means the same thing. Like we can increase we put a velocity, and then instead of it instantly changing, it's just a difference of velocity, right? That's what I'm assuming. So what we want to do is we've got 6 seconds. We're going to go 1, 2, 3, 4, 5, 6. So we're going to go plus, we have 6 seconds, so that's how that's going to work. Plus positive on the Y. After 2 seconds, we're going to go negative 10. Negative 5 on the Y, right? No, because that'll take us back to 0. So we need to go negative 10. But then aren't we going to be really fast? Or will it just take the difference away? Let's try it out. Here we go. And it should be 5. Yeah. 10 minus 5. Okay. So that's how it does work. It's the same as the location. You don't just set a new number value. You have to include the previous value. I'll move this deck box and stuff over here. But yeah, I went and binged some videos after that. Oh, we didn't read Surveyor 1. On June 2nd, 1966, Surveyor 1 became the first US spacecraft to make a soft landing on the moon. About 4 months after. We already read this one. Thanks to its retro... Yeah. We already read this in the previous area. Let's go. 4.2. We've got a cup of lemon tea here to help us along. It's my worst nightmare puzzle. So it's going to go 5. So we're going to go here. And after 1 second, we're going to go -5. And we're going to stop still for 5 seconds. Well, we figured it out. It only took us like 40 minutes to figure out that you could stop the car and then just wait the time out. I don't know what it was. I was just thinking, when I start moving, I'm moving now. I don't know why I had that in my head, but that's a very stupid thing to have in my head. Did we read Leonardo da Vinci? Here is Leonardo da Vinci. He's an exemplary experimenter and inventor. He tried to design flying machines and invented the dynamometer, a device measuring the magnitude of a force. He contributed to several fields of science. For example, he observed the resistance of air on an object, and he discovered capillarity. That is the way a liquid behaves in a tube. I don't know what I clicked on. That was okay. Well, we clicked on a new puzzle, but I'm going to jump back out because it said 4.5. And then Federico Grisogono. He was the first to claim that the moon and the sun cause the tides. The crater does not exist. 4.3. New thing. Introduction to mines. So we're not allowed to drive on the mines, I'm assuming. So we can change velocity twice, and we can change our starting position. So what I'm thinking is we can't change our initial velocity though. So we can only change velocity twice. So we want to start down here and we want to go 1, 2, right? So we're going to start at at 0, -10. And we are going to move 1, 2, 3, 4, 5, 6. So we're going to go positive on the y-axis after... Oh, it's after 1 second you've got to do it. We're going to go 1 second and then 2, 3, 4, 5. And then we need to get here in 1 second. So we'll do that twice as fast. So at 1 second, we want to be moving positive on the y-axis. 1, 2, 3, 4. And then it should be by 5 seconds. And then at 5 seconds, when we're here, we need to move no longer on the y-axis. So we'll -5 there, and we want to move positive 10 on the x-axis because we want to move there twice as fast. Okay. Let's see if we got this one. There we go. We had to wait a second for that one. And boom! Lovely. Lovely. Wow, if I turn this game up, it seems very, very loud. Let me turn it down for you guys. Turn that way down. Nikolaus Copernicus. It's Copernicus. He proposes to put the sun in the middle of a solar system in order to simplify the calculations, allowing to predict the movement of the planets. According to him, Ptolemy's system, in which the Earth at the center of the solar system made the calculations too complex. Influenced by Plato, he proposes that the movement of the planets is perfectly circular. We know now this is not correct. It was only on his deathbed that he asked one of his students to publish his manuscript. This one proposes to put the sun in the center of the solar system. At the time, it was dangerous to propagate ideas that went against the teaching of the Bible. But yes, as we know, a lot of these men were condemned. More than 70 years after his death, his writings were officially condemned by the church. Yep, and if he was alive, he would probably be burnt at this freaking stake or something. People be loco, guys. Watch out. People hate science. I don't know what it is. People hate the truth. On December 24, 1966, ho ho ho, Luna 13 became the third lander to make a soft landing on the moon. That seems like a really modern picture. I think that's a picture of the concept in a museum, like a newer picture. Thermometer readings estimate temperatures of roughly 120 degrees Celsius in broad daylight on the surface of the moon. Luna 13 took 5 panoramic photos of the moon. It was also equipped with devices and explosives that were used to measure soil density. All right, let's go. 4.4. Nothing new here. The new ones have a little exclamation mark above them. So, we're going to move negatively along the X, and then I'm assuming shoot up here. We have 6 seconds, so 1, 2, 3, 4, 5, 6. All right. So, we want to move negatively across here for 2 seconds. And then at 2 seconds, we want to move positively in the x-axis. So first, let's reset that back to 0. And then we want to move positively on the x-axis Wait. 1 second. Sorry. Yeah, negatively on the x-axis here. And then we want to move... Continue, we want to be positive on the x-axis, actually. So we're going to stay the same. It's just that we're going to also increase our y value by 5. So then we go 1, 2, 3, 4, 5, 6. Yeah, that would have been a mistake. 1, 2, and then we'll start moving up here. 3, 4, 5, 6. Perfect. Sweet. Just beating it into our heads now. Beating the logic in a little bit. 4.5, something new. Introduction to button batteries. We need to press a button to activate a battery, I'm assuming. This is Giovanna Battista. It says Giambattista Benedetti. He's considered a precursor of Galileo. He had a great influence on this one. He believes that it is only the rectilinear straight line impulse that is retained, not the rotational motion. Okay. As we know, that's also incorrect, because if you just spun something around in space, it would continue to spin any angle, right? It's not going to... Although I was just thinking, some things do behave really weird though, and there is a good Veritasium video on it. I remember Chris Hadfield, the Canadian astronaut. Is it Chris Hadfield who was talking about it? Basically, you have like a little... Imagine like a screw going into a wall, and it has like these wings on the edge of the screw, right? So you can screw it in like this by just holding it. And if you like flick it out and it comes out of the hole, it starts like spinning in space, and then after a while, it rotationally flips 180 degrees, but it actually goes at like a weird angle over the top of itself and starts spinning the other way. It's really bizarre. Really bizarre. You should check that out. That's something else I'm gonna have to add to the space screw thing. I have to add everything I talk about into the description now because I get complaints mostly by my friends that you mentioned this game's like another game, but then you never could remember what it was called, so you should add it into the end. So now I'm just making notes all the time. Okay, this battery is activated with the press of a button. You must stay on the button for the amount of time indicated. So we can't change our initial position, but we can change velocity starting and then 1, 2, 3 times. So we can go 1, 2, 3. We can't do that. 1, 2, because we've got to stop once as well. We can do it 4 times. 1, 2, 3, 4. Sorry, so correct. 1, 2, 3, 4. All right. And this would be if I go... Could I do that? That would be 2 seconds though. This would be 1 second, 2 seconds, 3 second, 4 seconds. So I've got 1 second, 2 second, 3 second. Okay, so this is what we're going to do. I'm trying to calculate how many seconds I need to be in each place. To do this angle, I need to move this bit in 1 second because I need that harsh angle. So that's going to be 2 seconds to the here. 1, 2. 2 seconds on the battery, that's 4 seconds. To get up here is 1 second, 2 seconds because of the harsh angle, which is 6 seconds and then 1 second to here. The starting. So we're going to start off by going positive 10 and positive 5 on Y. So 5, 10. In 1 second, we're going to hit here. And then we need to go down this way. So why don't we first reset this? So now these are currently, this will make us stop dead. And then we need to go positive 5 on the x-axis to go here in 1 second and then here in 2 seconds. So we'll go so actually we don't need to change that because that's going to be, we actually only need to go this by 5 then because it's going to go from 10 to 5. So we only need to go -5. And this one we are going positive 5 and now we need to go -10. So we actually need to go -15. 5, 10. That should get us to here. And that should happen after 1 second. 1 second, then we go here. And then after 2 more seconds. So 3 seconds. Now we need to stop dead still. 1, 2, 3. We stop dead for 2 seconds to 5. So we need to stop dead, which is going to be... We are going to be moving positive 5 a second. So we need to go -5 on the x. And we're going to be moving negatively y. I'm confused. Negatively y a second. So we need to go positive y. And that should stop us dead on the button. Then at 5 seconds, we need to go -20 on the x and +5 on the y, because we're going to go -20, +5, -20, +5. Let's have a go at this. Let's see if this works. We've walked through it in kind of a pseudocode kind of way. Perfect. Perfect. I'm loving this. I'm having a real good time. I'm having a really good time. Trying to trick us with the a lot with the displacements. Like, you can't just put in a new number. You've got to calculate from the previous velocity. I like that. Francois Viette. Here is Francois Viette. His way of dealing with and solving equations using letters to represent known as unknown variables has greatly influenced modern algebra. In this sense, he is often considered the father of algebra, although he did not invent it. It is the origin of the x and y axis system we still use today. Oh, okay. Very cool. He would have deciphered a message from a king in Spain during a war. The king, when he realized that the message had been decrypted, when he believed it was impossible, complained to the Pope that black magic had been used against him. Not black magic. Science. Let's go. Maths. Science. They just did it. You got science in the sense that you've got to test. You've got to be able to replicate, right? That's okay, we've got 7 seconds, so we can go. Thing is, here we can change velocity 1, 2, 3, 4. So we're gonna go 1, 2, 3, 4, 5, 6. 1 second. It doesn't matter if we just wait here an extra second anyway. So the first thing we need to do is move up here, which is negative on the x, positive 15 on the y. That's 1 second to get here. At 1 second, we want to stop dead. So we need to go the opposite. We need to go positive 5 on the y and positive x and positive 15 on the y. So now we've moved 1 second, 2 second. Then we need to go positive 15 on the x and minus 5 on the y. So after, oh, that's 3 seconds. Not that it matters. Doesn't really matter. We just spend an extra second here. That means nothing to us. And then we need to go, what did I say? Positive 15 on the x, negative 5 on the y. So we go 15 minus 5, 15 minus 5. That'll get us here. And that'll take 2 seconds. So now we're at 5 seconds. This will take us 6, 7 seconds. So at 5 seconds, we get there. And we want to be stopping dead. This is a blue one. So we'll leave it at 0, 0, because that means it's going to give us an immediate velocity. It's not a delta velocity. It's not a change. So here we go. Up to the left, stop dead. Did we not stop dead? What did I do? Go back. In 1 second. At 1 second. So we go here and we stop. Did we not stop? Negative on the x-axis, and now we're positive on the x-axis. Oh, I didn't do this negatively. So we're just increasing our speed to 30 meters a second. That was very silly. Just shot myself up into the wall. Okay. Great, and then we just stay there. And then, boom. This game is, it's scratching every itch that I have, every puzzle game itch. Here is Tycho Brahe. He made the most precise astronomical observations 10 times more of his time before the telescope arrived. He proposes a model which is a hybrid between the system of Copernicus, where the sun is at the center of the solar system, and Ptolemy, where the Earth is in the system. The 5 planets visible to the naked eye, Mercury, Venus, Mars, Jupiter, and Saturn, revolve around the sun, while the sun and the moon revolve around the Earth. Still, they have to make it revolve around the Earth to be confusing. He discovers a new star, which we call today Nova de Tycho, or SN1572, of course SN1572, and proves that this one is located beyond the solar system. This new star was in fact a supernova. That is to say, a star which at the end of its life had just exploded, which made it visible to the naked eye on Earth for a few years. Oh, very cool. He would have lost in a duel with a distant cousin the tip of his nose. Partially disfigured, he would then have worn a metal prosthesis to replace his nose. Wow, that would have looked funny. Just like a big metal tip on the end of your nose. I think I'd just rather have Flat nose. 4.7. Although, maybe I'd rather have a flat nose right now, because this one is a... This is a corker. Right. Interesting. Interesting. I can change velocity 5 times, and we can change. So we can start here and then go 1, 2, 3, 4, 5. Nothing really difficult about this. We'll start negative 15, positive 15. So negative 15, positive 15. Then we need to move in 1 second. We need to move positive 15. So 15 on the X, 5 on the Y. So we move here. And then at 1 second, which is correct, we are going to move here, which is the same velocity on the X, but negative on the Y, which means we need to go back to the 0 and then back again. And then at 2 seconds, we need to go 10 less on X, because instead of going 15, now we only want to go 5, so we're going to knock off 10. And we are going down Y at a pace of 5, and we need to go down at 15. So we're going to increase this by 10, but in the negative, because we're going down. And we're going to hit here, and we've got to... Wait a second. I'm confused now. Don't you have to wait here? Each one of these seconds? Oh, no, that's when they arrive. So this is... Yeah. Is it? I'm confused by this now. I'm confused. I thought we had to... Oh, it's not a button. That's just when the buttons are going to... That's when they're going to arrive. So it just means we have to go clockwise. That's fine. We're already there. So we start here. We move to the first one. We move to the 2 second one. We move to the 3 second one. And now we need to go... Continue going the same on the X... On the Y-axis, sorry, negative 15. But we need to now, instead of going positive on the X, we need to go negative. So we'll jump back to 0, and then back to negative 5. And then, once we're here again, we need to go negative 15 on the X. So increase that by negative 10. And instead of going negative 15 on the Y, we'll need to go negative 5, so we're going to increase that by positive 10. Let's see if I've done this correctly. It's a lot of little things that we need to get done. Okay, great. Fantastic. You just got to walk yourselves through it. Walk yourself one at a time. Simon Stephen. It complements the static physics introduced by Archimedes by improving the theory of the lever, the concept of the center of gravity, and the conditions of equilibrium on an inclined plane. He dropped 2 marbles, one of which was 10 times heavier than the other, and they hit the ground at the same time. Contrary to what Aristotle said, the weight therefore did not seem to have a real impact on the speed of an object falling. This is always really weird because I find that a very easy thing to test, right? Get a rock. I guess it's the problem is you still want it to be the same shape and size, just heavier. Maybe it was harder to get different materials, way back when, but I don't know, it shouldn't have been that hard to make a ball out of wood, right? And then a ball out of rock, but sure. He dropped 2 marbles. Yep. Contrary to what he said, there we go. Speed of falling. It is the origin of the decimal notation that we still use today. This notation allows us to write, for example, 1/2 is 0.5. I love you. Genius. He understood that the perpetual motion of an object is impossible, since there is always friction in reality, not in space. Not in space. That's where we are. What's this? Change 5? The 5th Chang'e mission developed by the Chinese national... Oh, it is Chang'e, but that's strange with the apostrophe. Mission developed by the Chinese National Space Administration landed on December 1st, 2020. It's the first mission since Luna 24, 1976, to return a sample of lunar soil to Earth. The Chang'e 5 landing site was carefully chosen. Indeed, the age of rocks from the region where Chang'e 5 landed is estimated to be only 1.2 billion years old, while the Apollo and Lunar missions have recovered rocks dating from 3 to 4 billion years. Chang'e 5, by bringing back to Earth about 1.7 kilogram of lunar soil, will help us better understand the formation of the moon. Chang'e mission owes its name to the goddess of the moon in Chinese mythology. Very cool. Well, that's level 4 done. Area 4. Let's move on. This one's a huge one. So see if we can get kind of this area knocked out in this video, and then we'll try and go for this one in the next video. Okay. Sea of Rain. Here's the Sea of Rain. There's another sea that was formed by the impact of a celestial object. That would have been about 250 kilometers. Had a diameter of 250 kilometers. It has a diameter of over 1,000 kilometers, which makes it one of the largest impact craters in our solar system. It was Giovanni Riccioli who gave the name to most of the seas in 1651. He decided to name the craters in honor of scientists and explorers. Let's go. There's going to be a new thing now. Introduction to the concept of acceleration. Oh, geez. Here we go. This is going to start breaking us down. This is where we lose. This is where we start losing. Laser beam module installed. Ready to apply an acceleration to the car. By the way, Mr. LaFlamme, if you need some help redoing some of this text to English, because I can... It pretty much is readable, but there's just a lot of issues, and I can help you do that if you would like. With our laser beams, you will now be able to accelerate. Thanks to acceleration, each second, the length of your displacement will change. It will get bigger and bigger if you're accelerating, or smaller and smaller if you're decelerating. To avoid any calculation in the table in our instruction manual will be very useful to you. Yes, I remember this. Oh, here's the acceleration. So, time in seconds, 2 seconds. Meters per second, it's going to go from 1 to 4. So it's going to go up by 3, and then 5, and then by 7, it's going up by odd numbers. That's Y. 1 to 2 is, what are we looking at? Table giving, if A is constant, okay, acceleration is normal, yep. Initial velocity is equal to 0. Oh, okay, yeah, when we start. Okay. Okay. And then this is going up, so this is going up by 3. This is going up by 6, so it doubles. It's going up by 9, so it's just going up by multiples. Alright, okay. We might have to refer back to that, but we'll see. All we can do is we have no initial velocity, and then we have an acceleration. And we have to be from 0 seconds to 4 seconds. So if we just increase the x by 2, and then every second it's going to increase. So we're going to increase it by 2. Every second it increases. 1. We need to get to 35, right? We need to get to 35. So here we go. Times 6 seconds. We only have 4 seconds. So let's look along here. This is, we can only get to 40 before we crash though. So what if we do this? We want 8. We've got 4 seconds. We need to go up by 8 meters a second, right? Go to 36. Oh, 3. 3 meters a second. Okay. 2, 4, 6, 8. Yeah, no, I want to go 8 for 4 seconds. No. For 3 seconds, but we can't do that. We have to be at 4 seconds. Huh. In 4 seconds. How do we do this? Okay. 4 seconds. And we don't get to decrease as well. So currently we're going at this and we have 4 seconds. We're going to get to 16. If we put it up to 8, we get to 32, which isn't quite there. If we do it to 6, we go to 48, which is too much, right? Let me just try this out. 6 would go to 48. That button being there is very confusing to me. I know it's supposed to be the cross at the bottom, but it's like, this is a full screen page. Usually when you have a full modal view, the cross will be at the top. Okay. So here we go in. We're looking 4 seconds. We're going to go 48, which should kill us. 6, right? Let's have a look. This should kill us. Because we would hit 48. Yes. Correct. Okay. Good to know then. So we can use this table. Well, this is 0 to 4 seconds. There's not really much we can do about that. We have to accelerate for 4 seconds. But we need to get to at least 30. Maybe 32 is actually enough here. Does look like it's okay. So we want to just go to 4. I mean, we can't really do much else anyway. It's because now we're, instead of being in the middle of squares, like exactly. Now we're on 32 out of 35, so that's a little bit strange. We haven't seen anything like that yet until now. Okay. 52. Ooh. 52, 5.2. Okay. I want to change our initial position. And we want to change it to this, of course. Don't forget that to avoid any calculation, table is our instruction is very useful. Will allow you to complete each puzzle on the first try. Yes, we will use that. So this is where we are, but positive 10 on the Y, sorry. We're going to pop up here. And then we have to accelerate to a negative 36, 30, I guess 37, which is the same, isn't it? 37, where are we going? 36 here. It looks like 36. So we want to go 3 seconds on 8. Although we have 8 seconds. We don't want to do that. We want to get there in 6 seconds, don't we? What's this? We want to get there in 6 seconds. So 6 seconds here. We want to get to 36. So 2. So we know how to change this to 2. And that's going to be for 6 seconds. It's going to be just negative 2. And then when it hits there, we can change the velocity at 6 seconds to 0, 0. So it stops dead. And then we need to move negative 20 in 2 seconds. So whereas negative 20 in 2 seconds means a speed of 10. So minus 10 because we are going in the negative. Okay. This should do. Sip of lemon tea, look at that. Spot on. At least we're getting way more batteries per level now because there are 570 to collect and we still have nothing. We don't even have a fifth of them. Who is this guy? Giordano Bruno. His most outstanding work was the Apology of Copernicus and severe critiques of Aristotle. Without providing proof, he was convinced that the universe is infinite. After a 7-year trial and after refusing to repent for his ideas, he was burned alive. He understood that the movement of the Earth is not perceptible by its inhabitants, nor on the object of the ship, going at a constant speed, which amounts to what are now called Galileo's transformations. He endangered himself by boldly asserting the existence of other suns and other Earths with other inhabitants, then again by denying the virginity of Mary, then further by engaging with magical practices. Sick mustache though, bro. John Napier. He invented the logarithm, which is the inverse mathematical operation of applying an exponent to a number. Logarithms are greatly simplified multiplication of large numbers. It quickly became instrumental in facilitating astronomical calculations, among other things. He also invented a small mechanical machine called the Napier stick, which made it easier to calculate products, quotients, powers, and roots. I have never heard of that. Wait a second. No. Napier stick. He simplified the decimal notation introduced by Simon Stevens into the format we still use today. The logarithm also led to the invention of the slide rule. Ancestor of the calculator, which was used in schools until 1975, until the invention of the portable electronic calculator. The slide rule was invented by William Oughtred, only 6 years after the invention of the logarithm. Very cool. Let's move on. This is a new thing, introduction to the concepts of acceleration and deceleration. So now we need to know when to start slowing down as well. Perfect example, because we don't want to hit the stick. So we start here with no velocity. That's totally fine. And then we can speed up for 2 seconds and slow down for 2 seconds. But it needs to equal 35. We can't go further than 35. So what can we add up for that? We probably want 35. So these two aren't going to cut it. In fact, because we have 4 seconds. So we've got 2 seconds and 2 seconds. Okay. 28. Got 32 here. Is 32 enough? I think 32 is enough. So, why don't we go 6 for 2 seconds? Oh, sorry, 10 for 2 seconds. Positive 10. 0 to 2 seconds. And then we'll go down to 6. Oh, -4 to 6 for 2 more seconds. Okay, let's see. Am I doing this calculation correct? We'll see. Let's give it a whirl. Because this should move us 20 in 2 seconds, and then we should slow down, but we didn't, because we're still going too fast. Because we need to go negatively more than that. Okay. I think what we might need to do, actually, is go to... Well, if we go -10, we're going to just slow down completely, aren't we? So, go to 1632, so we want to go 8. If we go to 8, and then we go to -8, that we get halfway and then start slowing down. Okay. And that should still hit 32. Okay. Okay. We got it. We got it. Understood. Understood. Galileo. Here is Galileo, who discovered that if an object experiences constant acceleration, the displacement is proportional to the square of the time interval elapsed since its departure. Modern physics began with this discovery by using a long inclined plane, allowing him to dilute the effect of gravity and neglect air friction. He discovered that the falling time of an object is independent of its weight. We already knew that, though. He stated that an unconstrained object will hold its momentum at constant speed indefinitely. According to Galileo, this included the rotational motion of the planets. We know now this to be accurate. Though today it's fairly common to use an idealized situation to explain principle in physics, he was the first to imagine the free fall of an object, a simplified situation in which the air resistance is 0. At the time, it was far from obvious. He understood the predictive power of mathematics. Because of this, he is now considered to be the father of modern physics. I got to say, have you ever seen them use a space station that they use a super vacuum to suck all of the air out of the room, and then they drop feathers, like a feather and a bowling ball, and they both hit the ground at the same time? It's incredible. I'm going to add that video to the description as well. Feather bowling ball. They take out all the air resistance, and they both hit the ground at the same time. It's incredible. Feather and bowling ball. It's down in the description below. God, I watch too much YouTube. Okay. God, he's got 5 out of 15 in this one. With great rigor, he boldly defied popular beliefs of the time and used only experience and ideation to develop his scientific theories. He tried to determine without much success why water cannot rise higher than a certain height in a tube. We know now this is due to the atmospheric pressure. While bored during mass, he discovered that pendulums can be used to measure time with considerable precision. The frequency of the pendulum does not depend on the amplitude of the movement. He is the first to question the assumption that light propagates instantaneously. He unsuccessfully attempted to measure the speed of light using a refracting telescope, which his work greatly improved. He observed mountains on the moon and sunspots, which went against the Greek Platonic principle that anything celestial is perfect. Using his astronomical telescope, he was able to observe satellites around Jupiter. It was the first time that we clearly saw a celestial body revolving around an object other than the Earth, which ran counter to the Ptolemaic model. Using his astronomical telescope, he witnessed the phases of Venus and concluded that the Copernicus model, whereby the sun is at the center of the solar system, is the only one consistent with observations. This was the nail in the coffin for Ptolemy's geocentric model. His findings got him into trouble with the Catholic Church, but unlike Giordano Bruno, he recanted and declared on his knees that his writings were heresies. That got him placed under a house arrest for the rest of his life. Legend has it that after having taken a false oath in court so as not to suffer the same fate as Giordano Bruno said, and yet it turns, speaking of the Earth and the Copernicus system. Pope John Paul II exonerated Galileo in the name of the church in 1992. God, I was alive then. That's it's ridiculous. The church, yeah, caused a lot of problems for a very long time. That's so good. He's just like on his knees, like, nope, everything I was written, totally out of order. It's heresies, all a mistake. And then he's walking out of there, and he's just like, I'm right though. Still correct. Oh my God, we have 3? Why? We have 8 seconds. We've got to wait there for 4 seconds. So we've got to, you know, actually hit 0 at some point. So we need to reach negative, I want to say 7, 8, 9, 8, negative 8, 7, yeah, let's say 6, 7, 8, 9. I guess around 8. We want to reach negative 8 in 2 seconds. So 8 in 2 seconds is here. So we want to go negative 4. 2 seconds. And then we want to move a little faster and then slow down, is it? Where are we getting to? We can't go past negative 16, which is here, 16, for another 2 seconds. Because if we do this, if we go 8, we've got 8 seconds, by the way, and we've got to actually wait on this for 4 seconds. So we might be 2 seconds, 2 seconds, and then we're just waiting still for 4 seconds. So we're currently at negative 8. And we need to go a further negative 8. Huh. We need to go further negative 8, which means we want to go up here. How do we do this? How do you jump from one to the next? We're already at 8. And we need to go a further 8. And acceleration is constant, so we want to be slowing down. We want to. This is awkward. Why can we do this twice? Why do we have 3 of them? I want to go here. Negative 8 in 2 seconds. Then what we're trying to do is get from here to here. Do we stop? Do we want to go? No, because we have to reach there in 4 seconds. Or we're dead. Because we need to wait here for 4 seconds. Okay. Because if we got here, if we went to negative 16 in 2 seconds, we'd miss this. Oh my god. But now we're going, now we need to go another negative 8. This is getting us now, and this is only the beginning. This is only the beginning of Area 5. Ooh. I'm trying to think, how does this, the speed that we currently have, relate to this now? Because we're already moving, so this is from 0. This is from 0. Do we actually want to move and stop? No, we can't do that. We've got to move, move, move. I'll stop here. We've got to slow down onto that. So we've got to move and then move, stop. But we're all, the problem. I'm confused. Oh, wait a minute though. We changed the acceleration completely. This isn't like a displacement thing. This isn't a delta. So we can just change our acceleration immediately. So this is fine actually. So what we need to do is move a further 4 in 2 seconds and then slow down again. So actually from 2 to 3. Oh no, we can't. From 0 to 2, we hit this. And then from 2 to 4, we want to slow down. So we only go another 8, which is going to be 4 and 2 again, I guess. Negative 4 again. So we're kind of doing the same speed, but we're stopping ourselves and starting it again. And then we decelerate to 0, 0, which is just stops us dead. Okay, let's do this. Let's try this. Basically, something's going to hit us and slow us down. No. It didn't. Because we've got to decelerate. I want to see what happened, though, then. We went there, and then we just continued. 2 seconds, and then at 4 seconds, we were already dead. Yeah. Do we just do the opposite? To slow ourselves down? Let me see what this does. Yeah. And then we just wait, and we don't move. This doesn't do anything. Okay. Okay, so yeah, we're just going the opposite again. It's the same. I'm overthinking it. This is getting really, really good. This is getting really... This is 45 minutes in. Okay. Was that 5? Hans Lippershey. Here's Hans Lippershey. He was a lens crafter who would have created the first telescope. He worked in the same town as Zacharias Janssen, the man who allegedly invented the microscope. Lippershey created the microscope by affixing 2 lenses to the inside of a tube. Legend has it that it was Lippershey's children who realized that holding 2 lenses at a certain distance could magnify the appearance of distant objects. Another possibility would be that he had the idea of Zacharias Janssen's telescope since he was producing lenses to spy on people at the same time. He tried and ultimately failed to patent the telescope. Shortly after the telescope's invention, Galileo caught wind of it, and the rest is history. 5.5. Let's go. Couple more to do. This has been a really fun one. Okay, so we have 3 velocities, so this is the awkward part. So I'm thinking, this is about, what, this is 28 as well? But from 16, I think we go 16, I think we go to 16, we go 8 for a second, and then -8. Is that correct? 8 for a second, and then -8 to get here in Wait. We need to do that in 4 seconds. This is going to be in... Although we could just sit there. Yeah. Until 4 seconds is up. And then, from 4 seconds to 6 seconds, we accelerate from 16 to 28. So we need 12. And we have 2 seconds to do so, so we need to move at 6. Positively. Let's go. So you should go halfway here, then slow down and land on the battery. Oh, what the heck did I do? Oh my god, because we're going... What am I doing? 2 seconds, there we go. Sorry about that. Do that again. We didn't up this by a second, so we were going 1 and then... Nah, I've still screwed it up somehow. 0 to 2, we're going at +8, and then from 2 to 4, -8, which should bring us to a stop here, shouldn't it? Pretty much. And then... No. And then we move up for 2 seconds, we move at... Oh no! I didn't mean to do that. Where are we? And then we move here because we need a further 12. 12. Yeah, for 2 seconds. Yes. 6. So this works if we actually reach here by this time. Because we should have slowed down completely. But let me see what's happening. We're getting there. Why after 2 seconds are we not slowing? 0 to 2, +8. 2 to 4, -8. So why are we not slowing down? I'm confused. I don't know what happened here. Try that again. I want to see. We should get halfway and then slowed down by something. This isn't triggering, is it? From 2 seconds to 4 seconds. Is this triggering? I don't see anything hitting us to slow us down. In 2 seconds, we should reach... At 8, we should reach 16. What am I doing? We need to be at 4. That's why. I've done the calculations wrong. There we go. We're going way too fast. We're not even getting hit with the slowdown. There we go. And then we start moving again. Silly boy. I doubled it. I was doing it over more time. Doing it over more time, but we got it. Johann Kepler. He stated 3 laws that helped analyze the movement of planets much more precisely than ever before. One of his laws says that the planets move in ellipses and not circles, as it had been thought for nearly 2,000 years. According to this law, it is the Sun and not the Earth that is located at the focal point of the ellipse. By combining his laws with Copernicus' system, he succeeded in accurately predicting the movement of the planets for the first time in history. As Tycho Brahe's assistant, he inherited his precious data on the position of the celestial objects in the sky. He was particularly interested in the orbit of the planet Mars, which did not seem to describe a perfect circle. He believed that the force that makes the planets rotate around the sun was magnetic. He was the first to imagine that physics applied to stars and planets the same as applied to Earth. He introduced the term foci in reference to an ellipse. He was one of the first to use the logarithm, invented by John Napier in order to facilitate his astronomical calculations. Unlike Galileo, Kepler's thought process was a bit misguided. He placed as much importance on astrology as he did on astronomy. On top of that, it seems he was a professional astrologer. Oh dear. Inspired by Pythagoras and obsessed with the harmony of the world, he believed the distance of the planets was related to harmonics and music. Okay. Next. 3 more to go in this video. We've got 10 minutes left. Come on. We've got to be better from the beginning. Interesting. So we have to move here. We have to slow down on this 4 seconds. So we need to get to negative 16 in 4 seconds. So in negative 16 in 4 seconds. So that is negative 8 in 2 seconds. So 8. Here we go. That's 2, 4. 4 minus 4. We can go. Oops. 2 to 4. And we can go plus 4. So we should go move halfway and then slow down on here. And then we need to start moving from at 4 seconds to 10 seconds. We need to move from negative 16 to positive 20. So 36, which is here. That's over 3 seconds though. We need it to last how many? 6 seconds? We can't do that with 36. It's here, 6 seconds. Sorry, that's 2. Alright. Yeah, because we have 6 seconds. Alright, here we go. Halfway, then slow down, land on this. And then back the other way, and it's going to really slowly ramp up for 6 seconds. Sweet, we're getting the hang of it. The 40th star from Earth, TZ Arides. Achievement unlocked. The 40 stars. Okay. Excellent, you've already completed 40 craters. By my calculations, you've almost completed half of the craters you need to return to Earth. Very good. 5.7. Oh, I didn't look at Rene and Descartes. Descartes. Okay, so, once again, here, then back again. We've got 12 seconds this time. We've got to go positive 16. So we want to go positive 8 in 2 seconds. So 4, 2 seconds, 4. And then in 2 to 4 seconds, minus 4. Slow down to this. And then we've got to go from positive 16 to negative 16. So 32 in 8 seconds. So, oh, wait a second. In 8 seconds? Oh, we don't know how to do that. So we need to do this in a different way. We're going to go from there to there. So we're correctly at positive 16. And then we've got 2 more accelerations. I think we need to go negative 16 in 4 seconds. So 16 in 4 seconds. 16 in 4 seconds is 2. So we'll go negative 2 because we're going to be moving this way. And then at 8 seconds to 12, which is another 4, and it's another 16, I believe, we're going to decelerate. Let's try. So up, down, speed-wise, right? This is taking a while to get there, and then we start slowing down as well. Cool. I think we're getting the hang of this. We're getting the hang of this. It's not stumped us for a while. Not stumped us for a while yet. René Descartes. He's stated the law of conservation of motion, which simply came to be called momentum. There's an important stage in the history of physics, since regardless of the complexity of the phenomenon, there are certain physical quantities that are conserved. He combined algebra with geometry, which allowed equations to be graphed, allowing for easier and more complete analysis. He introduced the modern notion of work in mechanical physics. He stated that an object that is unconstrained continues its momentum in a straight line at a constant speed forever. He thus corrected Galileo's error of included rotational motion and paved the way for Newton. This statement would become Newton's first law and is now called the principle of inertia. He published the Discourse of Method, a treatise on the scientific method which made a profound impact on science as a whole. He discovered the law of refraction, a phenomenon by which light can be deflected when passing from one medium to another. He would have been prodigiously proud. I don't know what that's supposed to mean. Sounds like he's mean. What's this 1D? These 8 craters allow you to approach the concept of acceleration in one dimension. Oh no. And this is going to be 2D along an axis. And non-zero initial velocity to your acceleration. Okay. And then stars. 7 craters offer an additional challenge compared to this concept of acceleration. This is going to kill us. Pierre de Fermat. To explain the refraction of light, a phenomenon by which light can be deflected when passing from one medium to another, he asserted that light always takes the path which minimizes its travel time between 2 points. This assertion forms the basis of a principle that will prove very important to explain the foundation of mechanical physics, the principle of least action. His analysis of curves in mathematics makes him one of the precursors of infinitesimal calculus. This field of mathematics, which is still of great importance in physics today, and served as the building blocks of a new physics introduced by Newton. Independently from Descartes, he links algebra to geometry. He is one of the founder of the theory of probability. Awesome. One of his theorems, which mentions that there is no integer n greater than 2 that respects the equation xn plus yn equals zn, was not proven until 1994 by Andrew Wiles. Okay. Last level. Let's go. Last level. For this video. We've done all the world for... Ooh. We've got to move here and we've got to move here. Is what I'm seeing. We've got 6 seconds to do so. And we get 3 accelerations. So... we need to accelerate 5 to 10. How do we do 10? On this axis here. Huh. We have 1 second to reach that, really? Do we go 12 and then like at a weird angle? Seems like that might be the way. Going to 12 and then like... that seems crazy. Because this is the only way to... in 1 second? Oh no, this is after. This is yeah. 1 second to 2 seconds because we need to calm down. So we're gonna go 5 and then right. So we're gonna go 10 and then -10 on the y-axis. Idiot, silly boy. And then -10. So we're gonna go 5 and then 5. That's gonna be over 2 seconds. And then we should have stopped on this point. And then we have from 2 to 6 seconds. So we have 4 seconds. We need to reach 32. In 4 seconds, 32, that's 4. Okay. Excuse me? Excuse me? What did we just do? What did we just see? That was crazy. No. No. What is going on here? From 0 to 1. We do nothing. Why are we doing nothing from 0 to 1? What are we doing? We're supposed to be going... We're supposed to be going 10 on the y-axis. Right? For 1 second to go 5, and then negative 10 on the y-axis. To slow down after 1 second. So we're going to reach here. What did I do? What did I input? Oh, I put it down here. Oh, I screwed that up. I was going to say, and then we should just move across there at constant speed. Constant speed, accelerating for 4 seconds at 4, which is going to be 32. Okay. Because it's squared, obviously, right? Okay, Otto van Guericke, I don't know who this is. Using his newly invented vacuum pump, he created vacuum in two half spheres facing each other. He then made a spectacular experiment using 8 pairs of horses to separate the 2 hemispheres. Against all expectations, the 2 hemispheres remained joined. The experiment highlighted atmospheric pressure. Oh. While trying to understand how gravity works, he unwittingly created the first electrical machine. It sparks and creates phenomena of electrical attraction and repulsion by approaching objects. Amazing. On November 17, 1970, Luna 17 landed gently on the moon in the Sea of Rain. It was the first lunar lander to deploy a small vehicle remotely controlled from Earth to the surface of the moon. The vehicle, named Lunokhod 1, drove for 11 days and covered about 10 kilometers. Look at these wheels. Lunokhod 1 was equipped with several antennas, 4 television quality cameras, a device for analyzing the density and mechanical properties of lunar soil, an X-ray spectrometer, an X-ray telescope, a detector of cosmic rays, and a laser. What a beast. Well, that's the end of that. I'm super enjoying this. We've done a lot of this game now. Of the simple parts of this game. This is covered. We're into the grit. Right? We're in the trenches. We've got a long way to go here. 6, I remember being quite... it's pretty okay size, but then 7, there's quite a lot as well. But look at that. We've only got 100. We've done 1/5, and we're already like a third into World 5 out of 7. All these are going to have more batteries. And we're going to... There's a couple of 5 challenges here, but then there's some 9 challenges thrown in just for fun. We're going to see... we're going to see what we can get done next video. Maybe this set here. Maybe these 2. But my god, these ones are gonna be a pain. I'm excited though. That's Space Tow Truck. I'm loving this. I'm really, really, really liking this game. If you want to play this for yourself, I would highly recommend it. If you like the look of it, which kind of is also telling you to stop watching my videos because I'm giving you the answers. But yeah, go play the game and then come back and watch the videos. How about that? That we'll make it fair on both sides. You go play the game and then come back and watch the videos. That's Space Tow Truck. I think that's video 3. There's probably going to be a lot more because it's going to get harder and harder and we're going to be able to do less per video time. But I am seriously liking this. It is scratching, like I say, a lot of those. It's getting a lot of those puzzle itches. And we're only on difficulty 5. It's about to get up to start 7, 8, 9. These ones later on. Okay, there's only... They all start off easy and then ramp up, and then I guess 7's just going to be insane. Where's there a 10? There's no 10. I've not seen a single 10 challenge, right? Where's the 110 challenge? There's got to be one of them at least. Because if you go here... 10. Blue. Dark blue. Maybe once we've done some, another little section opens up, but we'll see. That's Space Tow Truck. Thanks for watching, and I'll catch you next time. Bye.